Great to see you here. This is another video offered to you by the Ceuster Academy. In this video, I want to show you something special. But before I start, please do not forget to click the subscribe button, click on the bell so that every time we have a new video, YouTube will inform you. What is it I want to do here? We've been talking about earned value management, calculating estimates at completion, CPIs, SPIs, schedule variances, cost variances, and things like that. But in project management, we also saw a technique which was called PERT, or three-point estimation. And with PERT and three-point estimation, what we did, we looked at an optimistic, a probable, and a pessimistic evaluation of duration or cost. Now, what I want to do, and I didn't see many people do it before, is in fact linking those, bringing earned value management into PERT. And why do I want to do that? Well, when we spoke about earned value management, we spoke about an optimistic estimate. We looked at a probable estimate, and we looked at a pessimistic estimate. So first of all, when I hear optimistic, probable, and pessimistic, my mind immediately links this with PERT and three-point estimations. So that's what we're basically going to do. What is our project that we have? We have here the data. We want to build 20 widgets in 20 periods. One widget has a cost of 50K, and we are at a situation, we are at 50%, and we want to know what is our situation, what will happen. What did we do? We created six widgets, and the cost was 450K to create those 6 widgets. Now, when I translate this, first of all, my budget at completion is 20 times 50 is 1000K or 1 million. When we have 6 widgets at 50K, we have in fact created a value, an earned value of 300K, but we have an actual cost of 450K. Let's go back to my classical drawing, the lines. And what do I see? I have the evolution of the cost over time, like we planned it. It's a linear approach. We're at 50%. So we are at half, 500, and the budget at completion is 100K. So there's the basic information. We calculated that the earned value at 50% is 300K, and the actual cost at 50% is 450K. The first thing we can do here is calculate the variances. Remember the schedule variance. The schedule variance was earned value minus planned value. And in our case, we have earned value 300, planned value is 500. So in our case, the schedule variance is minus 200K. It means our project is behind schedule. Now let's take a different color, red, for the cost variance. The cost variance is, per definition, the earned value minus the actual cost. We have an earned value of 300, an actual cost of 450, which means that the cost variance is in fact minus 150K. So basically, in our project, we are late and we are over budget. We calculated the schedule variance and the cost variance, but what we want to know is in fact what will be the final cost of our project? What will be the estimate at completion? And in order to calculate those parameters, we have to calculate the SPI, the CPI, and the CSI. Let's start with that. So first we have the SPI. SPI is earned value divided by planned value, which is in fact earned value is 300 divided by 500 is in fact 3/5, which is also 0.6000. So this is an exact number. The CPI First, the definition is in fact the earned value divided by the actual cost, which is in this case 300 divided by 450, which is also equal to 1 divided by 1.5, and that's equal approximately to 0.667. We have a lot of decimals here, but this proportion is perfectly correct. So I'm using those because the calculation will be always correct. Now let's look at the CSI. The CSI is in fact the SPI times the CPI, which is equal to 3/5 multiplied by 1 divided by 1.5. And when we calculate this, we find 0.400, which is an exact number. It's not, let's say, approximately, it's exactly 0.4. Using the fractions in some cases is a lot easier when you put it in formulas. I prefer to use the fractional expression when we are dealing with numbers with repeating decimals. Typically, a number with a repeating decimal is a specific number in mathematics. We can identify them and we can write them as a fraction. So these are things that you can find in some mathematical courses. Now we have the SPI, the CPI, and the CSI. And based on those, we can in fact calculate the different estimates at completion. So we calculated the SPI, the CPI, and the CSI. In order to calculate the estimates at completion, we don't need this SPI, but we have it here anyway. We did need the calculations to calculate the CSI. Let's now look at the optimistic estimate. The optimistic estimate is the mathematical estimate. And it means we are considering the work that has been done, the money that has been spent. We cannot change that. So we have AC plus the remaining work. What is the remaining work? Well, it's the difference between what we want to do and what we did. So it's the budget at completion minus the earned value. And when we put it here, actual cost is 450 plus the back is 1000 minus the earned value is 300. So we find here 450 and 700. This is 1150K, which is the mathematical estimate, which is the optimistic estimate. Now for the probable estimate, we use the CPI. And there are two formulas. We can say we have the actual cost and the remaining part is going at the same efficiency, the same CPI. So we can use that. Or we can say we have the back divided by the CPI. And in our case, the CPI is 1 divided by 1.5. So it's 1.5 times the budget at completion, which gives us 1.5 times 1 million. It's 1,500,000 or 1,500K. So this is in fact the calculations that we have for the optimistic, the probable, and the last parameter to calculate is in fact the pessimistic approach. And for the pessimistic approach, we use the CSI. So for the CSI, we have to go back to this formula. So we have 450 plus 1 million minus 300 divided by 0.4. And when we calculate this, we find that we have here 700 divided by 0.4. So 700, 0.4 divided. Oops, I used I have to get my other glasses, 1 second, otherwise it doesn't work. 700 enter 0.4 divided and 450 plus, it gives me 2.2 million or 2,200K. So these are in fact the different calculations that we have, and we can use those to apply them on the PERT or the 3-point method. With the 3 estimates that I calculated before, the optimistic estimate, which is 1,150K, which is also the mathematical estimate, the probable estimate based on the CPI, we continue with the same financial performance, it's 1,500K, and the pessimistic, when we use the proportionality factor, the CSI, we find 2,200K. Now with this, I can calculate the estimate at completion at 50% probability, which is the optimistic, 1,150, 4 times the probable plus the pessimistic, and we divide this by 6. Now remember, there is a second formula which we call 3-point. You can use that formula also. There is a small difference in the outcome. It's a little bit more pessimistic than this, so the numbers will be a little bit higher, but in that case I have 1,150 plus 1,500 plus 2,200 divided by 3. When I calculate it here, the estimate at 50% will be 1,558K euro in our case. So that's the estimate that gives us a probability of 50%. So there is a 50% probability that we will spend more or less. 50% is not really good when we talk about averages. We also want to include another parameter, the standard deviation, and we can apply everything on the normal distribution. First, the standard deviation. Standard deviation is in fact the pessimistic minus the optimistic, also divided by 6, and we find that we have a standard deviation here from 117K euro. With these two numbers, we can calculate different probabilities. For example, what will be the probability that my project will be completed with a cost less than 1,700K, for example. That we will look in the next example when we're bringing these elements into distribution, into the standard distribution, and we will look at different calculations. Of course, a lot of different possibilities may exist. I will just give you 2 of them. We calculated the expected value, the expected cost with the 50% probability, the average. When we calculated or when we used the PERT formula, we found the standard deviation, and now we can put this in my attempt to draw a normal distribution. It looks a little bit like it, it's not perfect. Anyway, it's good enough to explain what's happening. We know when we have a normal distribution that with the average that we have a 50% probability that the cost will be less than 1,558K and 50% that it will be more. But we want to have a better indication. And when you remember the normal distributions, we also had confidence intervals. And we know that the surface here between the average and 1 standard deviation, or the average and 2 standard and 3 standard deviations, is always the same to the left or to the right hand side. Now we know that the surface here between the average and the 1 standard deviation is about 34%. And we can look at the confidence interval of 1 sigma, and then we have a 68% probability that the value is between the average minus the standard deviation and the average plus the standard deviation. So in our case, when we apply this, we can say that the expected at completion will be between the average minus 1 standard deviation, or 1,441, and the average plus 1 standard deviation, which is 1,675. Now this is 68%, and normally we don't like 68%, but we can also say what is the probability that the estimate at completion is smaller than 1,675. What is the probability here? When we look at this, this is 34%, this part, and this is 50%. So the probability here is approximately 84%. So we can say that there is an 84% chance that my estimate at completion will be less or equal than 1,675K. It also means that there is a 16% probability that it will be more. Now, typically in a company, we look at 80%. And now let's have a look what it means, or what the value has to be to have an 80% probability. Just imagine now that you're in a company and you want to have a probability level of 80%. Now, what is in fact the amount that you expect? What will be that amount that has a probability of 80% that you will not exceed it? Now, there are things about the formula. When we look at the normal formula, X is mu plus Z times sigma. And the Z value depends on the probability. For example, Z equals 1. That corresponds with a 34% here in this area. Now, when we look at that, what we did in the previous exercise was we said, well, we have 1 sigma here, and then we have about 84%. Now, we want to have 80%. So what is the Z value? And the Z value you can find either in Excel formulas, norm as dist, norm as inverse functions. You can find the relationship between the Z value and the probability, and the probability and the Z value. Now, when you do this, you will find that for 80%, the Z value is approximately equal to 0.8416, which also means that the estimate at completion at 80% will be approximately equal to mu plus Z1 times the standard deviation, sigma. Now, when we put that here, mu is 1,558K plus 0.8416 multiplied with the standard deviation 117, we find that this value is approximately 1,656K. It means when I want to be sure with 80% probability, I have to say that the level, the estimate at completion with 80% of probability will be 1,656K. And we can use that for further evaluation. Is this acceptable? What happens with parameters like net present value, internal rate of return, payback time, return on investment? Basically, when we look at this, we can introduce a parameter of probability using the estimates that we used before, the PERT and the 3-point estimates. Probably not many people have been doing this. I've not seen it in many cases, but it gives you a more probabilistic approach to your estimations. And I know typically managers want to have a fixed number, but we also know that there is the effect of probability. Things happen, we have variation, we have natural variation, and we cannot do anything about it. Looking at the estimations like this will give you additional information and tools to take the right decisions. What are you going to do? Will you continue with the project? Or will you do something else? Will you stop the project? Or are you going to take some measures to return success to your project? The thing is that all these things together are very important for you as a project manager, and you have to understand it. You have to know what's going on with your project. So this was the interpretation, the use of PERT or 3-point formulas on the estimate at completion parameters that we identified in earned value management. We look at other elements about earned value management later in follow-up videos. Anyway, this was the end of this video. Do not forget to click the subscribe button and click the bell. So basically, every time we put a new video online, YouTube will inform you. I thank you and looking forward to seeing you in the next video. Thank you. Bye-bye.